Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5.3. So with our parallel lines and perpendicular lines we've covered so far, what we haven't covered yet is how to deal with equations of them. And so that's what we're going to focus on today is writing linear, come back here. Okay, writing linear equations. And the next one we'll talk about determining distance between a point and a line. So first off, let's talk about definition of parallel lines. If two non-vertical lines have the same slope, then the lines are parallel. Okay. So we look at this one. Here's my given line, y equals negative 3x plus 1. As a reminder, to graph this, we've got this right here, b equals 1. It passes through the point 0, 1. Negative 3 is my slope, so that's m is negative 3, which is a negative 3 over 1. There's some reminders here of what slope-intercept form looks like, okay? 0b and b and all that. So I'm going to plot the point 0, 1, and then I'm going to apply the slope of negative 3 over 1. Remember, slope is rise over run. So for example, for negative 3, I can go down 3, that's a negative direction, then I would go to the right 1. I could also go up 3 to the left 1. So I can go 1, 2, 3 more and 1 left and 1, 2, 3 down and 1 to the right. Okay, so that's my basic solving. When I make parallel lines, then I'm going to start with the fact that it has to match up the slopes. If I have this line here that says y equals negative 3x, okay, that slope means that that rate of change is going to be the same between the two. So we'll see what happens when I do this. Now, I'm going to make it a little bit easier on myself. I'm going to pick something like a positive 5. And that's going to move it up to the 0, 5 for that starting point. So I'll go 1, 2, 3, 4, 5. From there, I'm going to apply my slope again. So I can go 1, 2, 3 up, 1 to the left, 1, 2, 3 down, 1 to the right. And then I got one more space here, so I'll go that way again. As I draw those points, you notice the lines are traveling the same exact direction. And they're never going to cross. And that's our key with this, okay? Same slope, but one more thing to add is different y-intercepts, okay? And just for the fun of it, let's do one more. So I'll do y equals negative 3x minus 7. Okay, so I go down to 0, negative 7. So 1, 2, 3, 4, 5, 6, 7. Okay, negative 3 is a slope, and I can go 1, 2, 3 up and 1 to the left. And I'll do that a few more times just to get a nice pattern. And I'll connect those dots. And again, you see everything is traveling kind of that same parallel direction. So with parallel lines, they're never going to cross, just like we saw earlier with our other lessons. So because these have the same exact slope, they're going to continue on forever without crossing. So let's use that to help us write this equation. Write an equation of a line that passes through the point 2, 4. And is parallel to the line here. That's so I got it as a function with the f of x equals 4x plus 1 there. Remember, parallel lines just has to have the same slope. So we're going to start with this. So I'm going to say, I'll just go with y. Y equals 4x plus b for now. So I don't know the b value, okay? In this case, I picked 2 of them that I just felt like would space it out nicely. In here, we want to make sure it goes to this point 2, 4. The thing to remember about that is 2 is x and 4 is y, which that's the same as does right there. So you can actually take the 2 and plug it in here and the 4 for the y, and look what happens. I now have something I could solve for b. So I'm going to go ahead and just work this through and solve it out. So I got 4 times 2 is 8 plus b, and I'll subtract 8 to both sides. So then I get b equal to a negative 4. Oops. Well, negative 4 again is the b value. I want the actual equation. So I'm going to write it out as y equals 4x minus 4. Again, quick recap. I started with the original function. I noticed the slope was 4. So I use that slope of 4 into a new equation, but I can't solve the b yet. But I can do it if I plug in the x and y that's given there. All right. And let's talk about perpendicular lines on a graph. Okay. So if two non-vertical lines have slopes that are opposite reciprocals, then the lines are perpendicular. Okay. So for example, here we got f of x equals negative 2/3 x minus 2. So I plot that, I'll go down 2. I'm going to go up 2 to the left 3, down 2 to the right 3, and then I'll go a little bit more. 1, 2, 3, 1, 2, 3. Okay. So there's my initial line. From there, if I want my perpendicular slope, so the slope here is negative 2/3. My perpendicular slope, which is I'm going to use that little perpendicular symbol to help with this, it's opposite reciprocals. So what happens is the negative 2/3 is going to flip. So it's going to be a 3/2. And since it started off as a negative slope, my new slope is positive. So that's the opposite part. So opposite means that we're going to take a positive or negative and swap them. And then reciprocals means we take a fraction and we turn it into that. We just flip it over. A over B becomes B over A. All right. So it's negative becomes positive, positive becomes negative, A or B just flips to the B over A idea. So if I want to pick up my own, I'm just going to start them with negative, or sorry, not negative 2/3, positive 3/2x. And I'll just pick, let's pick 4. And we'll go 3/2x minus 8. Okay. So for the first case, I got 1, 2, 3, 4 right here. 3/2, so it's going to go 1, 2, 3 up and then 2 to the right. We're going to go 1, 2, 3 down to the left. Okay. So there's that one. Or the other option I went with was, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. I can go 1, 2, 3 up, 2 to the right, 1, 2, 3 up, 2 to the right, and so on. Okay. So because they're opposite reciprocals, these are right angles. Okay. So let's use that. All right. Determine the lines are parallel or perpendicular. So here's what I don't have in these cases. I don't have the slope in every one of them. This one's easy. The slope is 4. So the other two, I want to transform it. The way it's written right now, I'm going to solve it for y. So that means I'm going to start off by subtracting 12x to, well, let's just write the whole thing. So I can subtract 12x over, and that does not combine with a 3. So I'm going to have negative 3y is equal to a negative 12x plus 3. Then I can divide every single thing by negative 3. So y equals, that'll be a positive 4x minus, minus 1 there. Okay, and for line C, I'm going to do the same thing, but I'm going to do it over here so that I can say that, let's see, 4y plus x equals 8. We're going to subtract x to both sides. So that 4y is equal to a negative x plus 8. Divide everything by 4. And that's a negative x divided by 4, which is the same as negative 1/4 x. And I'll add it to. Now, let's look at these. Here, my slope is 4. And here, my slope is negative 1/4. So to start off with, I think it's pretty clear to see that one's 4 and that one's 4. So that means A is parallel to B. Don't forget that's what this means. That means parallel. Okay, but when I look at another one, oops, negative 1/4, that is opposite reciprocals of 4. Okay, because remember, I can treat these as 4, 1. So flipping as 1/4, opposite sign is negative. That means that line C here is perpendicular to both, oops, A and B. So I can do perpendicular like an upside down T. So A is perpendicular to C, B is perpendicular to C. So these are the 3 cases from this. All right, and that is it for our beginnings of parallel and perpendicular lines. All right, did you get a chance to try out the U-try now problems on your own? 2 main ideas today: to be parallel, lines have to have the same slope, but different y-intercepts. Perpendicular lines have to have slopes that are opposite and reciprocals. Okay, and that's it for today. All right, have any questions, feel free to reach out. Otherwise, have a nice day.